हॅलो वर आहेत का तुम्ही 3 ला कारण परत ह्याचं काय वाजतं ना परत त्यामुळे तर मी खालून जॉईन झालो तू कारण त्या मॅडमची ह्याच्यासाठी येता का हे चालू होतं कुठे येतात तुम्ही नाही इकडे की आहे समोरच बरोबर नाही या तर की काम प्रॉब्लेम काय झाला माझं टाइम टेबल आम्ही तयार करतो टाइम टेबल करायचं आता ते चालू होतं त्यावेळेस सरांना म्हणलं तर 3 लाख घ्या म्हणले म्हणून मी हे झालं त्यामुळे वर आणलं या इकडे हेलो ऊपर नेट नहीं है इसलिए उनसे इधर बुला है यहाँ से लेक्चर लेता हूँ नीचे से नेट किधर है अभी देखा था वहां पे मैडम बोली कि नहीं है चालू नेट इसलिए तो मोबाइल कनेक्ट किया है नहीं यहाँ पे मैडम ने अभी चेक किया था नहीं आया बोले धुमाल मैडम नहीं वो कर रहा था मैं नहीं तो इसलिए मैंने एक इससे पहले वाला लेक्चर इसके लिए था अभी ये भी लेक्चर के लिए इसलिए तो मैं हाँ खाण्याला काय ओके Good afternoon, everybody. Today we have seen whatever part we have to be recorded in the last lecture, right? See, in last lecture we have seen that class AB type of the amplifier, right? Did you getting my voice? Please reply. Did you getting my voice? Please reply. आवाज येतोय का? प्रियंका पवार, धनश्री दळवे, आवाज येतोय माझा?
Yes, sir.
Okay. See, in the last lecture we have to study the class AB type of the amplifier, right? See, what do you mean by class AB? Whatever the advantages of class A, B, class AB, that we have to be revised again, and then we have to be start the class AB. That is a revised part. So before that, we have to be seen the class A type, class B type of amplifier, and whatever their things related to it, right? See, we know that class A amplifier is the amplifier which should be worked in case of your full 360-degree half cycle, means whatever the transistor used in case of your class A type of the amplifier, in that case this type of the transistor should be worked in a full half cycle. That is, full half cycle indicate that not only 180 degree, it should be a work with respect to 360-degree, right? So due to that, what happened, there should be burden of the one of the transistor, right? One of not the transistor used across there, right? So due to that burden, what is the thing that will happen? See, due to that burden, what happened? This is not worked, right? This is not worked in a long term, right? This life for that transistor is less. This will be happen in case of if we have to use the class A type of the amplifier, right? So for that purposes, what we have to do, we have to be work another type of the construction, that is a class B type of the amplifier. See, in this type of the configuration, we know that we have to be use the two transistor, right? We have to be use the two transistor for the purpose of the for the purpose of amplification operation, right? So it is nothing but a one transistor should be either your NPN or other should be PNPN5. We have to use the two different configuration transistors. See, reason behind it is we have to half cycle, either your positive half cycle, either your negative half cycle. So during the working of this two half cycle, we have the transistor which should be working in the two different configuration, right? So that's why we have to be seen the class B type of the amplifier for that. See, upper transistor considered as a NPN type of transistor, lower transistor should be considered as a PNP type of transistor, right? So NPN type of transistor that should be worked during the first positive cycle, PNP type of the transistor that should be worked second negative cycle, right? So alternately two transistor work in a different event, and it should be have whatever the input applied that should be amplified across your output, right? So the effect of it is that due to that, what happened, the burden on single transistor is not, right? So no burden indicate that life of that particular transistor is more. This will be happen when we have to use the class B type of the amplifier, right? So one of the important thing with respect to class B type of amplifier is that when we have to be use the class B type of the amplifier, in that case, whatever the signal amplifier by each transistor is not 360-degree. Why? Because here is a two transistor. One is worked with respect to 180-degree, other should be worked another 180-degree, right? So that's why operating time for particular transistor is not 360. It should be 180 for each transistor, right? So that's why whatever the Q point, this is called as Q point or operating point, or this is called as load line. So load line portion, the Q point is on the below section. That's why the part of this below section, that is a near about 0 to 120, that should be only coming with respect to this, right? This should be happen in case of class B type of the amplifier, right? So these are the things with respect to class B type of the amplifier. Then we have seen that one of the problem. This is the main thing with respect to the class B type of the amplifier, right? So problem coming, right? See, these are the one of the problem coming with respect to the class B type of the amplifier. This problem is called as crossover distortion. Now, to background of this crossover distortion, I'm telling you, right, why this crossover distortion should be coming with respect to the class B type of the amplifier. See, in case of your class B type of the amplifier, we have to be use the two transistor, right? So two transistor indicate that there should not be changes म्हणजे असं असायला पाहिजे की त्याच्या वेळेस जे इनपुट मिळते ना त्याचं आउटपुट रिप्रेझेंट व्हायला पाहिजे. असं का? कारण एक 180 डिग्री दुसरा 180 डिग्री वर्क झाला, फुल हाफ सायकल झाला, बरोबर असं व्हायला पाहिजे. कारण सिंगल क्लास मध्ये सिंगल यूज करतोय तो फुल सायकल हा चालतो आणि त्याचा आउटपुट विदाउट डिस्टॉर्शन येतं. Why the distortion coming with respect to this type of the configuration? See, when we have to be use the class B type of the configuration, right? When we have to be use the class B type of the configuration, it have zero biased voltage. I'm telling you, zero biased voltage indicate that we doesn't apply any DC voltage with respect to this type of the configuration, right? So zero bias voltage indicate that whatever means there is where, see why we require the DC bias voltage. See, DC bias voltage is the voltage which should be used where the output is not coming. Where is output is not coming. So during this portion, see, I'm telling you which are that portion, which are that two portion where output is not coming. See, it is also called as crossover distortion. There are two crossover distortion to indicate that transition from high, this is low to the high. It indicates that transition from 0 towards the upper level or the transition from 1 towards the 0 level, right? These are the two transition which should be coming with respect to your amplifier, right? So during that portion means in case of we have to use the biasing voltage, that is DC voltage, right? So that DC voltage, if we use, see, if we use, here we doesn't use, if we use that DC biasing voltage should occupy in this portion, so no noise is coming, right? No distortion is coming. But in case of your class B type of the amplifier, what we have to do? We have to be work the transistor such a way that it's one of the important point, that is cutoff point, or it should be as like as silicon or germanium. You know, silicon have 0.7 volt for the cutoff voltage, germanium have 0.3 volt as the cutoff voltage, right? So what it indicates that cutoff voltage during that portion, this device is not turn on, right? So no turn on indicate that no power, no voltage, no current flowing through the device, right? This will be happen. See here, from voltage changes from the 0 to the 0.7. Consider as here 0.7 volt. So during that portion, no transistor should be on. So that's why there should not be no output is coming across your this crossover portion, crossover position, right? This is related to the 0 to somewhat increasing level. This will be happen. Another thing means your output is changing from means up to the 0 to 0.7 volt, there is not output. After all, here also again 0 to minus 0.7, there also there is not conduction of any transistor. So that during that portion, see here, this is the two portion, this is the transition from 0 to minus 0.7. So no output is coming across here, and this portion transition from 0 to somewhat increasing level, right? So that during that portion no output. So this is not acceptable with respect to voice. Why it is not acceptable with respect to voice? See, this is also acceptable for the data. See, we have discussing with respect to the all of the things with respect to mobile network, consider as a mobile network, right? See, if we have telling something, right? To means when call is happen, right? See, when call is happen, in that case, if I am telling something, right? If I am telling something, what it indicate that समजा मी बोलत असताना म्हणत बोलतोय की मी सोलापूरला येतोय, लक्षात घ्या, आणि मी सोलापूरला येतोय, समजा सोलापूरचा पोर्शन आहे ना इथं आला, कन्सिडर करा इथं आला, हा तर काय होणार, मी येतो कुठं, लक्षात येतंय का? This will be happen. That's why class B type of configuration have the this crossover distortion, means it eliminates some of the data, right? That's why it is not applicable for the purpose of voice communication. Because see, ज्यावेळेस तुम्ही मोबाईल कम्युनिकेशन पाहताना दोन प्रायोरिटी असतात, लक्षात घ्या, voice and data. There is a highest priority with respect to your voice communication. There is a less priority with respect to your data communication. तेव्हा पाहिलं का तुम्ही कधी, तुम्ही जर काय काय वेळेस तुमचं नेट चालू नसतं पण डेटा म्हणजे व्हॉइस म्हणजे कॉल वगैरे कनेक्ट होतात पहा, द रिझन मेन इट इज दॅट, म्हणजे व्हॉइस डेटाला जास्तीत जास्त हायर प्रायोरिटी असते कम्पेअर टू द डेटा, लक्षात घ्या. ओके, क्रॉसओव्हर डिस्टॉर्शनचा कन्सेप्ट लक्षात आलाय का, नेमकं काय होतं आणि ते एलिमिनेट करण्यासाठी काय करायचं ते आपण पाहणारच आहोत. पण क्रॉसओव्हर डिस्टॉर्शन आणि त्याचा कन्सेप्ट लक्षात आलाय का सांगा मला, प्लीज रिप्लाय. रिप्लाय द्या. कुणालाच काय कळलं नाही का, असं काय झालंय का? म्हणजे याचा अर्थ असा होतो, जर समोरनं काय रिप्लाय येत नसेल तर काहीच कळत नाही. एकतर जास्त कळते, एकतर काय कळत नाही. सेकंड जास्त कळलं नसतंय, काहीच कळत नाही असा त्याचा अर्थ होतो. सांगा, खरंच कळलं नाही का काय? दळवे, प्रज्ञामाने, येस ऑर नो. नसेल तर मी रिपीट करतो, ते काय असेल ते आन्सर द्या. लक्षात आलंय की नाही? आणि नाही आलं म्हणलं तर काय फरक पडणार नाही, मी रिपीट करेन. लक्षात सांगू परत एकदा, प्लीज रिप्लाय.
येस सर.
ओके, रिपीट करतो. सी, व्हॉट डू मीन बाय क्रॉसओव्हर डिस्टॉर्शन? आय एम टेलिंग यू. सी, ऍप्लिकेशन पण तुम्हाला सांगितलं क्रॉसओव्हर डिस्टॉर्शनचं काय ऍप्लिकेशन होतंय की जेणेकरून ते कुठे यूज केलं जात नाही. कुठे यूज केलं जातं ते पण सांगतो तुम्हाला. सी, क्रॉसओव्हर डिस्टॉर्शन इंडिकेट दॅट when we have to be use the class B type of the amplifier, right? When we have to be use the class B type of the amplifier, in that case we have to be use the two transistor, right? For the purpose of the working of the two transistor for different half cycle. See, this is a PNP type of transistor, this is NPN type of transistor, right? So this is PNP type of transistor. We have applied the signal, it have flowing from 0 degree to the 360 degree, that is full two half cycle, right? This is applied to the input of this both transistor. So this signal is applied to the both transistor, right? So in this transistor is biased or applied voltage such a way that this should be working in a positive half cycle, right? So during this positive half cycle, it should be worked up, so that positive half cycle is coming across your output. But see, this will be happen at the case of positive, but at the negative half cycle, what happen? We have biased the another transistor, that is second transistor, such a way that which should be worked in a second negative half cycle. So that's why upper transistor have positive, lower have negative. So actually both half cycles should be coming across your output. This is a actually happen theoretically. See, this is happen theoretically, right? This is not happen in case of your practically. Means we have applied the input, that is positive, negative. So due to that, first transistor positive half cycle is coming, so this is the positive output coming across your output, right? So this will be happen. This is happen theoretically, but what happen? This transistor have one of the property. This should not be turned on below the cutoff voltage. Cutoff indicate that either your silicon or germanium, it have some of the voltage required to turn on it, right? So for that, if it is considered as a silicon, right? This your device should be constructed from silicon, so it have required the 0.7 volt voltage for the turn on, right? So during that 0.7 volt, up to that 0.7 volt, in case of your positive changing, it should not be worked, right? It should not be worked. Seen here. See, what happened? See, voltage consider as here. If the transition from 0 to 0.7 during that period, what happened? No one transistor should be on, right? So this portion is not coming in output. See, spike, this should be considered as a spike. This spike should be coming, right? This will be happen during the change from your 0 to 0.7 volt, right? So again, all other half cycle is coming across your output, but during second thing, see, it is nothing but a transition from your 0 to the negative again, right? It is nothing but a 0 to 0.7 volt. During that portion also, no transistor should be worked. So that spike means no worked indicate that no output is coming across this type. So this is nothing but a crossover change from your 1 to, this is nothing but a 0 to 1 or 1 to 0, right? So during that portion, no output is coming across your device. This is as like as जर मी समजा बोलत असो आणि इन केस ऑफ मोबाईल कम्युनिकेशन मध्ये जर मी क्लास बी यूज केला तर तिथं काय समजा मी सांगितलं तुम्हाला, मी सोलापूरला येतो, तर सोलापूरला येतो ना काही पार्ट समजा इथं स्पाइक मध्ये गेला तर मी येतो तेवढाच पलीकडे ऐकू जाईल, लक्षात घ्या. म्हणजे जर मी क्लास बी यूज केला तिथं तर तो पोर्शन तिथला एलिमिनेट होतो, लक्षात घ्या. दॅट इज द डिसएडव्हान्टेजेस थिंग विथ रिस्पेक्ट टू द क्लास बी एम्प्लिफायर. ती रिमूव्ह करण्यासाठी आपण ऍक्च्युली काय करतो हे पाहणार आहोत. लक्षात येते क्रॉसओव्हर डिस्टॉर्शन काय असतं आणि त्याच्यामुळे काय इफेक्ट होतो. सम ऑफ द इन्फॉर्मेशन लॉस होते, लक्षात घ्या. म्हणून व्हॉइस कम्युनिकेशन साठी म्हणजे इन मोबाईल कम्युनिकेशन मध्ये क्लास बी यूज करत नाही, डेटासाठी यूज केला काय प्रॉब्लेम होत नाही. लक्षात घ्या. लक्षात आलंय? प्लीज रिप्लाय द्या. लक्षात आलंय? ओके. See, we have seen the class AB type of amplifier. Why we have to use the class class AB type of amplifier? See, we know that class B amplifier have one of the disadvantages, that is spike. It is nothing but a crossover distortion which should be coming with respect to class B type of the amplifier. To remove that class B spikes coming or the crossover distortion coming with respect to class B amplifier, we have to be design the one of the other type of amplifier, that is a class AB type of the amplifier. See, when we have to be seen the class AB type of amplifier, this is the amplifier which we have to be use the positive thing of class A and class B, right? Positive thing of class A and B. So that's what happened. So whatever the operating area of your transistor, class A, it is a 0 to 360 degree. Class B have the 180 degree, right? So we have to be design the amplifier which should be in between of the class A and class B. This is nothing but a class AB type of the amplifier. So that's why the operating area of the class AB type of the amplifier is greater than 180 but less than 360. That is nothing but a 0 to near about the 270 volt, 0 to 270, right? 0 to 270 degrees centigrade, right? Why it is or less than 270 but greater than 180 degree? Why it is? Because see, we have problem only due to the crossover problem, right? Means crossover indicate that when the portion changes from your crossover, either your 0 to 1 or 1 to 0, in that case no portion is coming across your output. So when we have to be use the class B type of amplifier, this amplifier should be worked during the overcoming the part of your crossover point. जे crossover point च्या जर पुढे वर्क होतोय ना, तर crossover distortion याचा प्रॉब्लेमच नाही, right? That's why we have to use the class AB type of the amplifier. So when we have to use the class AB type of the amplifier, which should be work greater than 180 degrees, so no crossover problem coming with respect to class AB type of the amplifier, right? So for that purpose, what we have to do, we have designing the amplifier, right? We have designing the amplifier. In that amplifier, we have used the two diode, right? One diode is used in a positive half cycle, another diode that should be used in another half cycle, that is negative half cycle. So during the portion, see, during the portion where crossover is happened, during that portion, it gives the sum of the voltage, right? It gives the sum of the DC voltage. So that whatever the point, crossover point, no voltage is coming with respect to class B. This will not happen with respect to class AB type of the configuration. This is due to the we have providing the sum of the DC biasing voltage through the diode, right? And that DC biasing voltage applied across this diode, there should be one of the effect coming, that is a no crossover should be coming with respect to the class AB type of the amplifier. So that's why the operating period of this type of the amplifier is greater than 180 and less than 360. That is the reason behind it is. So for the working of the 180 degree, means more than 180 degree, it have providing the sum of the biasing voltage, right? Biasing voltage indicate that direct DC voltage provided to the transistor, right? This will be happen with respect to class AB type of the amplifier. See, above figure shows that the diagram of the class AB type of the amplifier, right? So this is the amplifier. See, no any other change with respect to class A and class B. Sorry, class B and class AB type of the amplifier. Only thing changed here is we have to be use the two diode which should be worked in a alternating half cycle. So that's that's why the period of this type of the class AB amplifier greater than 180, right? So during the portion of 180, more than 180, in that period, these two diode provide the biasing voltage. Biasing indicate that some DC voltage, which that DC voltage, whatever the effect coming, is see during this portion as well as during this portion, some of the signal loss in case of class B. This is not loss in case of class AB type of the amplifier. The same thing. Here is one transistor for positive, other is for negative. Negative indicate that smallest portion. Okay. So for that purposes, the Q point is not here. Q point indicate that operating point, because in this case, whatever the operating point that should be greater than 180. So that's why Q point position is not here, it should be shifted over earlier part. Okay, so we have providing the input signal, we have got this type of the output signal with respect to the class AB type of amplifier. So effect of the crossover that should be eliminated by the class AB type of the amplifier, right? So as we have seen the amplifier start up with the class A to the class AB, we have increasing the efficiency of this amplifier. म्हणजे सिग्नलची जी पॉवर आहे ना ती वाढत जाते आणि त्याच्यामध्ये इफेक्ट ऑफ द क्रॉसओव्हर असेल किंवा जे त्याच्यामध्ये डिसएडव्हांटेजेस इफेक्ट आहेत ते रिड्यूस होतात. See, we have seen the another type of the amplifier, that is class C amplifier. See, class C amplifier is the amplifier which have operating half cycle, means whatever the operating cycle or whatever the output coming, which should be less than 180 degree, right? Means if we have to be apply the signal, that is a full signal, it is indicate that 0 to 360 degree signal applied across your input, right? So for that your output we doesn't give the all of the signal, means input applied that should not be coming with respect to your output. It have smallest, means smallest signal which should be less than 180 degree should be coming across your output. That's why class C what it indicate that input is applied at full 360 degree half cycle, output got it is less than 180 degree. So what happens, some of the portion, see some of the portion of the signal, some of not indicate, more portion of the input waveform that should be eliminated. याचा अर्थ काय झाला माहिती आहे का? समजा मी एक्झाम्पल घेऊया, समजा मी कॉलेजला जात आहे, साधं एक वाक्य, 4 वाक्य, मी कॉलेजला जात आहे, राईट? त्याच्यातलं काय होतंय, समजा 180 डिग्री म्हणजे 50% डेटा आला, राईट? मी कॉलेजला जात आहे, समजा त्यातले समजा पहिली 2 वाक्य किंवा लास्टची 2 वाक्य आली, मी कॉलेजला तर येईल, पुढचं काहीच येत नाही, जात आहे का, काय करत आहे का, काय नाही, म्हणजे मी कॉलेजला तरी, म्हणजे मी कॉलेजला तरी एलिमिनेट होईल किंवा जात आहे तरी, म्हणजे मी कॉलेजला त्याचा काही इफेक्ट होत नाही, जात आहे कुठं, लक्षात घ्या. म्हणजे काय याच्यामध्ये होतं, इफ वी हॅव टू यूज द क्लास ए बी टाइप ऑफ द एम्प्लिफायर, इन दॅट केस व्हॉट एव्हर द इनपुट सिग्नल अप्लाइड, if we have to be considered as it have 4 sentences, right? So 4 word, so that 4 word out of 2 word is going, right? This will be happen in case of class C amplifier, but also this have highest amount of the efficiency, but it have highest efficiency indicate that ratio of output to the input is more, but if it is used for the audio, it is acceptable or not? Tell me. मी आता तुम्हाला एक्झाम्पल पण सांगितलं, तर त्याचा इफेक्ट काय होतो ते पण सांगितलं, हे ऍक्सेप्टेबल आहे का व्हॉइस कम्युनिकेशन साठी, सांगा. येस ऑर नो आन्सर द्या, डिटेल मी तुम्हाला सांगतो, येस ऑर नो. रिप्लाय द्या. क्वेश्चन कळला का, सांगा मग आन्सर. येस ऑर नो, फक्त 2 ह्याच्यात सांगा. धनश्री दळे, पल्लवी कोकरे, कोण सांगेल? येस ऑर नो. हा, रिप्लाय द्या. प्रज्ञा माने, वाघमोडे, सर्व गोड, मी परत एकदा सांगतोय, क्लास सी एम्प्लिफायर लक्षात घ्या, समजलं नाही असा त्याचा अर्थ होतो. क्लास सी एम्प्लिफायर इज द एम्प्लिफायर which should be worked less than 180 degree, right? 180 degree indicate that if we have applying the signal that is full 360 degree half cycle, right, that should be applied to this type of the transistor. So we have using the configuration such a way that this is called as LC. LC indicate that resonance circuit, parallel resonance circuit. This is tuned up for particular सिग्नल. म्हणजेच काय सांगतो, आपण जर रेडिओ चालू करतो ना, रेडिओ त्याची जर फ्रिक्वेन्सी, म्हणजे समजा लक्षात घ्या, रेडिओ चालू करायसाठी आपल्याला रेडिओ रिसिव्हर लागतो, ट्रान्समिट करत नाही तुम्ही, राईट? रिसिव्हर लागतो, तर रिसिव्हर करण्यासाठी आपल्याला समजा आकाशवाणी सोलापूर पाहिजे, कन्सिडर करा, त्याची फ्रिक्वेन्सी असेल 1092 किलोहर्ट्ज समजा, लक्षात घ्या 1092 किलोहर्ट्ज आहे. मी एक्झाम्पल सांगतोय, ऍक्च्युली आय डोंट नो. 1092 किलोहर्ट्ज समजा फ्रिक्वेन्सी असेल, सोलापूर किंवा पुणे आकाशवाणीची असेल. जर तुम्हाला ते ऐकायचं असेल रिसिव्हर, तर काय करावं लागतं, तेवढ्या फ्रिक्वेन्सीला तुमचा रेडिओ ट्यून करावा लागतो. लक्षात घ्या, ट्यून करावा लागतो. ट्यून करण्यासाठी इंडक्टर आणि कॅपॅसिटी एलिमेंट यूज केले जातात. लक्षात घ्या. त्यानंतर तुमच्या अॅम्प्लिफायरला ते सिग्नल मिळते आणि तो तुमचा आउटपुट म्हणून मिळतं. लक्षात घ्या. राईट, दिस विल बी हॅपन. राईट, याच्यासाठी लक्षात घ्या, हिअर व्हॉट वी हॅव टू डू. सी वी हॅव अप्लाइंग द फुल 360 degree signal to this type of the transistor, right? Full 360 degree have cycles applied across here. So we have to be use this type of the configuration is class C type of the amplifier, right? So this should be biased or worked such a way that it should be worked less than 180, right? So whatever the output coming is less than 180, so indicate that this is the output. तर याच्यासाठी समजा, म्हणजेच तुमचा ऑपरेटिंग एरिया जो आहे ना, जे क्यू पॉइंट हा बिलो असतो. लक्षात घ्या, बिलो याच्या बिलो असतो इकडे. त्यामुळे फक्त लेस दॅन 180 तुमचे सिग्नल आउटपुट येते. याचा अर्थ मी तुम्हाला सांगितलं की चार लाईन सांगितले मी आता. चार तुम्हाला सेंटेन्स म्हणजे सॉरी 4 वर्ड बोललो होतो. कोणते कोणते, समजा मी कॉलेजला जात आहे, राईट, हे 4 वाक्य असतील. तर यातले कुठलेही 2 तर 50% समजा लॉस. 180 म्हणजे 50%, त्यापेक्षा कमी आहे खरं तर, पण 50% आपण कन्सिडर केला. तर यातले 4 वाक्य जर या इथं असतील, या एवढ्या पूर्ण याच्यामध्ये, त्यातली 50% म्हणजे 2 जर लॉस झाली, तर काय होतंय, 2 शब्द म्हणजे 2 शब्द आहेत ते जातील, राईट, आणि 2च राहतील. त्याचा अर्थ काय होईल, म्हणजे सेंटेन्स जे आहे ना, ते ऍज इट इज पूर्ण मिळणार नाही तुम्हाला. तर हे व्हॉइस कम्युनिकेशन साठी ऍक्सेप्टेबल आहे का नाही, सांगा. सर्व गोड सांगा लवकर. ऋतुजा, सर्व गोड सांगा. ऍक्सेप्टेबल आहे का? एक्झाम्पल थ्रू देऊन सांगितलं. समजायला गेलंय काय, काय प्रॉब्लेम आहे? ऍक्सेप्टेबल आहे का? येस ऑर नो? येस ऑर नो सांगा. काय कळतच नाहीये मला, सांगा बरं काय तुमच्या अंकल की रिप्लाय द्या. चालू आहे ना, आवाज येतोय? आवाज येतोय? माझा आवाज येतोय?
Yes, sir.
आन्सर द्या ना काहीतरी. मी काय म्हणतोय, व्हॉइस कम्युनिकेशन साठी हे ऍक्सेप्टेबल आहे का? येस किंवा नो. आन्सर चुकला तरी काय प्रॉब्लेम
No,
नाही.
sir.
नो, राईट. व्हाय इट इज नो? लक्षात घ्या की जर आपण बोलत असेल एखादं वाक्य, त्या वाक्यातला काही पार्ट गेला तर चालणारच नाही ना. लक्षात घ्या. त्यामुळं व्हॉइस कम्युनिकेशन साठी क्लास सी टाइप ऑफ द अँप्लिफायर कधीही यूज केला जात नाही. कुठल्याही व्हॉइस कम्युनिकेशन साठी ऍप्लिकेशन साठी यूज केला नाही. So that's why the application of class C amplifier is not a audio amplifier, right? Why? Because when we have to use the class C type of amplifier, it have higher efficiency, but other effect of it is that due to that some of the information should be lost, right? So that's why it is used for the purpose of another application. You have seen the application of it. See, due to its heavy audio distortion, I'm telling you, heavy audio distortion indicates that if we have to be telling the forward to our lost, right? This is not acceptable, right? So that's why class C type of the amplifier not used for the audio frequency amplifier. It should be used for the high frequency amplification of the sine wave, right? So for that purposes, it is used for the purpose of long distance communication of the differentiation, right? It is also used for the certain type of radio frequency amplifier. Radio frequency indicate that RF, you know, radio frequency, the frequency which should be in a kilohertz. Kilohertz मध्ये ज्या frequency आहेत ना, ज्या काही ऑपरेशन साठी यूज केलं, ऑपरेशन indicate that in case of your some of the devices they require the radio frequency signal. सिग्नलचे टाइप आहेत लक्षात घ्या. ऑडिओ फ्रिक्वेन्सी म्हणजे काय झालं 20 हर्ट्ज टू द 20 किलोहर्ट्ज, राईट. 20 किलोहर्ट्जच्या पुढची फ्रिक्वेन्सीची सिग्नल असते ना तर रेडिओ फ्रिक्वेन्सी सिग्नल असं म्हटलं आता. डिफरंट ऍप्लिकेशन जसं की मोबाईल कम्युनिकेशन असेल, परत म्हणजे मायक्रो ओव्हन ओव्हन माहिती आहे ना त्याच्यासाठीचं जे कम्युनिकेशन असेल त्या डिफरन्ससाठी आपण रेडिओ फ्रिक्वेन्सी सिग्नल यूज करत असतो. सो पर्टिक्युलर रेडिओ फ्रिक्वेन्सी amplifier application we have to use this type of the class C type of the amplifier, right, where the pulses of the current produced at the amplifier output can be converted to the complete signals of the particular frequency by the use of LC resonance circuit, its collector circuit. What it indicate that, see, we know that we have to use the particular RF configuration. RF indicate the radio frequency configuration of the amplifier. In that case, what it does, see, it have to be remove all of the signal, whatever the signal coming, it should be removed into the small portion. Small portion indicate that small pulses, right? Small pulses म्हणजे जी पूर्ण साइन वेव्हची फॉर्म होती ना ती लहान 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 पार्टच्या पल्सेस मध्ये डिवाइड करतात आणि ती डिवाइड केलेले सिग्नल जे आहे ना ते पल्सेस तुमच्या LC रेझोनन्स सर्किट म्हणजे रेडिओचं एक्झाम्पल दिलं होतं, राईट. त्याच्यासारख्या सर्किट मध्ये हे त्याच्यासारखं ऍज आउटपुट म्हणून कलेक्टर सर्किट मध्ये यूज केले जातात. लक्षात घ्या. म्हणजेच लक्षात घ्या क्लास सी एम्प्लिफायरचे ऍप्लिकेशन काय आहेत की ज्यावेळेस आपण हे जर यूज केलं ना फॉर द ऑडिओ फ्रिक्वेन्सी एम्प्लिफायर तर त्यावेळेस काय होणार आहे काही पार्ट लॉस होणार आहे. लक्षात घ्या. मग ते ऍक्सेप्टेबल नाही. पण जर हे एक लक्षात घ्यायची इफिशियन्सी मोर आहे, राईट. इफिशियन्सी मोर आहे म्हणजे ऍप्लिकेशन भरपूर असणार त्याची, राईट. त्यासाठी काय करतो आपण क्लास सी कॉन्फिगरेशन अशा प्रकारे यूज करतो की जेणेकरून तुमची सिग्नलची स्ट्रेंथ वाढावी, जी इफिशियन्सी जास्त म्हणजे सिग्नलची स्ट्रेंथ वाढावी, but that not affect the audio signal, right? That's why class C type of the amplifier used for the purpose of sine wave oscillator, which should be used for the purpose of radio frequency signal, right? That are the application of the this type of the configuration. It also used for the purpose of radio signal tuning. म्हणजे समजा तुम्हाला आकाशवाणी पुणे केंद्राचं लावायचं असेल तर त्यासाठी तुम्ही काय करणार आहात त्या फ्रिक्वेन्सीला जाणार आहोत. लक्षात घ्या. जे तुमच्याकडे नॉब असतो त्या नॉबला पण जे असं फिरवत राहतो, राईट. ज्यावेळेस ते केंद्र लागतं त्यावेळेस काय तर त्या फ्रिक्वेन्सीला तुमचा नॉब ट्यून झालेला असतो त्यावेळेस ते लागतं. त्यासाठी क्लास सी टाइप ऑफ द एम्प्लिफायर यूज केला जातो. ओके, हे लक्षात आलंय का? लक्षात आलंय का क्लास सी टाइप ऑफ द एम्प्लिफायर, राईट. आता वी हॅव डिस्कसिंग द all of the thing with respect to the efficiency of different amplifier, right. See, we have seen that operating area of the particular amplifier and the efficiency of the particular amplifier here. See, we are discussing start up with this diagram. See, this is class A, class AB, class B, class C, and D2. D2 indicate that it is the pulsating, right, on and off portion, right, this type of the amplifier, right. So we have seen that efficiency, see, this is the 0%, means start up with A to the D type of the configuration, we have to be increasing the efficiency. याची efficiency कमी आहे. See, याची efficiency कमी आहे. पण जसं आपण इकडून इकडल्या कॉन्फिगरेशन मध्ये जाऊ ना तशी efficiency वाढत गेलेली आहे. लक्षात घ्या. See, this is the efficiency, right. So when we have to be use the class type of the configuration, in that case it should be whatever the input signal applied that should be coming with respect to your output. But see, it also what happened, whatever the output coming that have less strength, right, near about the 48%, 40 to 45% is the efficiency of the class A type of the configuration, which will be the CN here across here, right. As we have to be seen another configuration, not a B, right, class AB type of the configuration. During that configuration the efficiency is greater, that is near about the 50%, right. When we have to use the class B type of the amplifier, in that case the efficiency is greater than 50%, right, greater than 50%, that should be related to the up to the 75%. If we have to use the class C type of amplifier, it also efficiency which should be greater than 75%, right. And when we have to use the D2T, D2T indicate that it is nothing but whatever the input applied that should be distributed in a small pulses, right. Small pulses indicate that in case of digital signal, right, you know analog and digital मध्ये काय फरक आहे. analog म्हणजे जे आपण बोलतोय ना व्हॉइस ते analog सिग्नल आहे ज्याच्यामध्ये positive, negative अशी up cycle आहेत, right? So digital indicate that it is either 1 or 0, right? That are the only change with respect to digital signal. So in case of digital signal, we have not seen this D2T configuration, but D2T configuration, what it does, so whatever the signal applied, that signal should be divided into the small portion as a digital pulses. That pulses is coming across your output, and that pulses gives the highest amount of efficiency, near about 95% efficiency, which should be coming with respect to D2T type of the amplifier. Okay. What it does, class A, class AB, class B, class C, and D2T type of the amplifier. See, as we have traveling from class A to the class D2T type of the amplifier, efficiency should be increase or decrease? Tell me, increase or decrease? इथं दिसतंय बघा, या पोर्शन पासून इथून अशी वर गेले म्हणजे increase होणार की decrease होणार?
Increase.
Okay. So in this case, in case of your class A towards the class D2T type of the amplifier, as we have changes from class A to the class D2T, there should be increase in the efficiency. So that's why for the application of where we have requirement of the less noise, that is higher efficiency, in that case we have to use the D2 type of the amplifier. Now all of the mobile network communication, we have to use the D2T type of the amplifier for the amplification of whatever the voice as we have to be used. Just related म्हणून सांगतो, ऍक्च्युली मोबाईल कम्युनिकेशन ज्यावेळेस सुरू झालं होतं ना, त्यावेळेस पाहत असाल की तुम्ही इनकमिंग कॉलला पण पैसे होते. लक्षात घ्या. सध्याची थिंग असं आहे की एकदाच रिचार्ज केला ना, समजा 666 कन्सिडर करा, तर 3 महिने तुम्ही इनकमिंग आउटगोइंग तर फ्रीच आहे, तर त्याला हेच नाही, पण डेटा पण मिळतो. म्हणजे लक्षात घ्या, याचा मिनिंग काय मला सांगायचं की टेक्नॉलॉजी मध्ये ग्रोथ झाला. लक्षात घ्या, टेक्नॉलॉजी मध्ये ग्रोथ झाला. जसं की ज्यावेळेस सुरू झालं त्यावेळेस 1G होतं, 1G टेक्नॉलॉजी होती. आता 5G टेक्नॉलॉजी आली. इन जपान देअर शुड बी 6G टेक्नॉलॉजी रनिंग नाव. लक्षात घ्या, 6G. आता इंडियात पण 5G मला वाटतं जिओची येईल, राईट. म्हणजे लक्षात घ्या, जी इंडिकेट दॅट व्हर्जन वाढत जातात, जेणेकरून स्पीड ऑफ द डेटा वाढत जातो. लक्षात घ्या, व्हॉइस डझंट हॅव एनी इफेक्ट, राईट. व्हॉइसला जो आहे ना त्याच्यावर इफेक्ट राहत नाही, कारण व्हॉइसला जे अम्प्लिफायर यूज केले जातात ना, नॉर्मली क्लास AB टाइप ऑफ चे अम्प्लिफायर जास्त करून यूज केले जातात, कारण की लॉस ऑफ इन्फॉर्मेशन कमी होते. आणि ते सध्याला इन केस ऑफ मोबाईल कम्युनिकेशन older time means during 1G session this should be used. During this 4G or upcoming 5G, they have to be used the D2T type of the amplifier, because whatever the signal coming that have highest efficiency. Okay. See, amplifier class by conduction angle. We know that we have to be seen the different 5 type of the amplifier configuration or amplifier class. We have seen the 4 type of the configuration, that is class A, class B, class AB, and class C. These are the 4 type we have discussed. Plus we have to be somewhat discussed with respect to class D2D. That is not part of our syllabus, but for future need, means in our application we have to use the class D2 type of the amplifier. That's why we have to be seen this, right? So for that purposes we have seen the operating cycle of the particular configuration, right? We have seen that class A type of the amplifier, right? So class A type of the amplifier is the amplifier which should be operating is full 360 degree. It indicates that operating area for that configuration is 2 pi. 2 pi indicate the full 360 degree half cycle. Class B indicate that this is the configuration which have operating area of the less than 360, which is nothing but a less than 360, which is nothing but only 180 degree. 180 is nothing but a pi. Pi indicate that 180 degree. So this is the conduction angle for the class B type of the configuration. Class AB. See, we know that due to the use of class B, there should be one of the problem coming, that is crossover distortion. So we have to be removing this crossover distortion by applying the 2 diode, right? So one diode is used in a positive, other is negative. So that's why whatever the configuration desired for the particular is greater than, that's how whatever the conduction angle that should be greater than pi. Pi it is nothing but a 180. right? So that's why we are designing the class AB type of the amplifier, right? So class AB type of the amplifier, we must requirement of the operating period, operating cycle is must be greater than 180. So that's why the period of the particular class AB is greater than 180 and less than 360, right? This is the thing happen with respect to class AB type of the amplifier. We have designing the class C type of the amplifier. See, class C type of the amplifier is the amplifier which have whatever the output coming, that should be less than 180. 180 indicate that it is a pi. So operating period for the class C type of the amplifier is less than 180, right? See, I'm already told you related to the class D2T type of the amplifier. See, this is basically digital type of the amplifier. Digital indicate that it have only the pulses, right? We have to be seen one of the subject. You have the one of the subject in a third year, that is signal and system, right? That in a third year, that subject, see, signal and system in that subject, you have to be seen the pulses, right? These pulses we have designing the pulses which is less near about zero, म्हणजे खूप smallest portion असतात. It should be indicated as a it should be as like as near about zero. It is not actually zero. It is 0.00001, right? So it should be considered as a zero because it is a pulse, small angle pulse, right? So due to the use of this class D2T type of the amplifier, it should become a small pulses. Due to that pulses, it should be act as a digital. So that's why it have more application in case of your mobile communication. Okay, class D2T type of the amplifier. Okay. See, this is class A type of the amplifier. It have operating area which is near about the 360 degree. Class B type of the amplifier which has operating area 180 degree. Class AB which have operating area greater than 180, less than 360. That is nothing but a class AB type of the amplifier. In case of class C, it have operating area less than 180, seen here, right? This is the class C type of the amplifier. रिवाइज करें उद्याच्या लेक्चरला वेळ आहे का भाऊ? See last. See comparison between different amplifier. See class AB type of the amplifier. See, we have already discussed this conduction angle, right? So I'm not again repeated it, right? Conduction angle for the particular configuration. We know A have 360, B have 180, C have less than 90 degree, and AB, C, which is in between 180 and 360. 180 indicate that pi, 360 indicate that 2 pi. So during between pi to 2 pi, that is class A beta of the amplifier. Position of Q point. We have seen that position indicate that where is the Q point is coming. In this case, both half cycles should be coming. That's why center of load line. Center of load line means whatever the load line म्हणजे काय सांगतो. This is called as load line. Q point म्हटलं जातं. याच्यावर जर Q याच्यासाठी पोझिशन म्हणजे क्लासेससाठी इथं Q पॉईंट असणार आहे, लक्षात घ्या. ऑपरेटिंग पॉईंट इथं असणार आहे. त्यामुळे काय होतं, वरचा पॉझिटिव्ह हाफ सायकल आणि दुसरा निगेटिव्ह हाफ सायकल हे सगळं याच्यात मावतं, लक्षात घ्या. ओके. Then position of Q point for class A, center. We have the exactly x-axis, near about x-axis. This is class A below the x-axis. AB have the in between the x-axis and the central load line. Okay. We have to be revise and some part of this taking next day. Okay. Stop करूया आपण, मीटिंगला जायचं आम्हाला. Okay. Attendance द्या fast. Roll number 1.
Present, sir.
1 minute. 2, 3,
Present, sir.
4, 5,
Present, sir.
6,
Yes, sir.
7, 8, 9, 10, 11,
Yes, sir.
12, 13,
Present, sir.
14, 15,
Yes, sir.
16,
Present, sir.
17, 18,
Yes, sir.
19, 20, 21,
Yes, sir.
22, 23, 24,
Yes, sir.
25, 26, 27, 28, 29, 30,
Present, sir.
31,
Yes, sir.
32, 33,
Present, sir.
34, 35, 36, 37,
Yes, sir.
38,
Yes, sir.
39, 40, 41,
Yes, sir.
42, 43,
Yes, sir.
44. Okay, option number 2, 4, 7, 8, 9, 10, 12, 14, 17, 19, 20, 21, 22, 23, 25, 26, 27, 29, 30, 32, 35, 36, 39, 40, 41, 42. Sorry, 44.
25 present, sir.
25 present. Okay. Ankhil?
29.
Ankhil?
41.
41. Okay.
29.
29. हो 44. Okay, stop करूया आपण.